Hello all of you. Welcome to the session on numbers. We will be dealing with the questions given in ICET, IP ICET as well as TS ICET on numbers. Numbers topic మనకి చాలా vast topic. ఉన్న అన్ని chapters లో ఉన్న ICET లో either it is pure maths or what we can say arithmetic based topics lo, it is definitely one of the vast areas we can say. So in this particular session we will be mainly focusing on the questions that were given in the recent past on numbers, and the numbers questions mainly will be dealing with divisibility rules, like with the LCM HCF, finding the last digit, finding the reminders, or finding what we can say LCM and HCF for the given numbers. In that we will be having various problems that are possible. So let's focus on the first question that is given here. Find the smallest natural number with which 900 is to be multiplied to make it a perfect square is the question. So 9000 is the number given to us, and if you observe carefully, perfect squares like 36 or for that reason 64, in that way what we understand is 36, if we write it as product of two numbers, it is 4 into 9, or if we go for prime factorization of that one, 4 is nothing but what? 2 square. Alone 9 manam we can write it as 3 square. So if we express it as product of prime factors, the indices will be having even powers. That is what is the point that we have to keep it in mind while dealing with perfect squares. So same way 9000, if we write it as product of prime factors, the easiest way is what we can say 9 into 1000. 9 manam further we can write it as 3 into 3, 3 square. 1000 is basically what? 10 cube. 10 cube we can write it as what further? 2 in 10 we can write it as 2 into 5. So what we can say is it's basically 3 square into 2 square. 2 into 5 means 2 cube into 5 cube. Further we can write this one as, right? So we should have the indices as even numbers so that the number will be a perfect square, we can say. So if you are observing the prime factor 3, the index is already even number we are having there. So that means we don't have to touch that 3 square part. But coming to the other two numbers, 2 cube we are having there. Multiplying with one more 2, we can make it as 2 power 4. That means the index now will become even, right or not? In the same way, 5 cube ni inko 5 to multiply yeste, we will be making it as 5 power 4, right? So we are making it as again even. So now what we understand, we are multiplying that number with 2 as well as 5. That means we are basically multiplying that number with 2 5s 10. So what is the least number with which 9000 should be multiplied so that the resultant is a perfect square? Means it is basically 10. So the question is mainly dealing with the prime factorization part. So as we thought earlier, for finding the number of factors, what we can say, or number of ways of resolving the given number as product of prime factors, prime factorization is required. So this is also one more case where prime factorization is useful. So we'll move to the next question. The question is mainly dealing with LCM and HCF. The LCM and GCD of two numbers are 1800 and 30 respectively. If one of the numbers is greater than 500 but less than 1000, then what is the other number is the question. So if you are observing carefully, LCM of the two numbers is given as 1800 and GCD is given as 30. And the point that we know from numbers topic is, if GCD of two numbers is 30, the numbers have to be multiples of 30. Let the two numbers that we are dealing be 30A and 30B. Here a point that we have to keep it in mind is A and B should be co-primes. They cannot have further common factors. If they have common factor, our HCF or GCD won't be at 30 level. So that means we should consider always A and B as co-primes. By the way, what are co-primes means? Two numbers which are not having any common factor are basically termed as co-primes. So 30A and 30B, where A and B are co-primes. That is what is the point that we'll be dealing with. Right. Now, if two numbers are 30A and 30B, their LCM will become what? 30AB, because A and B are co-primes we know. So 30AB is the LCM according to us, but according to the problem, the LCM is given as 1800. So what we understand then, dividing that 1800 by 30, we get A into B. So 1800 by 30 is nothing but 60 only or not? So A into B is 60. Now we are interested in finding two numbers whose product is 60 and they should be co-primes. So let us focus on the possibilities for this one. A into B. Suppose if you are considering A as 1 and B as 60. 1 into 60 is 60, 1 and 60 are co-primes, we can say. 2 and 30 we cannot consider because though 2 into 30 is 60, 2 and 30 are having 2 as the common factor. So I am ignoring that. So let's move for 3 and 20. 3 20s is 60 and 3 and 20 are not having any common factor. That means they are also co-primes. 4 and 15 is one more case where the two numbers are co-primes. Then same way 5 and 12 is also one more case where we can think about the two numbers as co-primes. 5 12s is basically 60. 5 and 12 are co-primes. Further possibilities, if you are looking at 6 and 10, it won't be co-prime case. 7 is not dividing, 8 is not dividing, 9 is not dividing, 10 again will be repetition of that 6 and 10 or 10 and 6. So these are the four possible cases. Now, giving these values or substituting these values in 30A and 30B, we get the original numbers. So in this particular case, what we can say, the numbers will be 1 and 60 means 30 into 1, 30, 30 and 16, 30 into 16, 1800. So this particular case, the numbers are 30 and 1800. But the question says, the two numbers, one of the numbers is greater than 500 but less than 1000. This is not that case we are basically interested in. Same way here, 33 is 90, 30 20s is basically 600. So definitely this is one of the numbers is satisfying this condition that greater than 500 and less than 1000. We just quickly look at the other two cases also. 34s is 120, 30 15s is basically 15 3 is 45 means 450. So this is not in the range of that 1000 to 500 or 500 to 1000. The last one also will be having 35 is 150, 30 into 12 is 360. 360 is also not in that range. So that means the only possibility is what? 90 and 600. So what is the question now? Out of these two numbers, if it is one is between 500 and 1000, what is the other number? That means we are not interested in 600. We are interested in the other number 90. So what is the other number here? 90. So question is definitely not easy. If we know that co-prime concept and using this possibilities concept, then we will be getting the answer based on the given condition, right? So let's look at one more question dealing with numbers, different aspects of numbers. So we will move to the other one. So let's look at one more question that is mainly dealing with again LCM. Find the smallest 4-digit number which is exactly divisible by 13, 15 and 23 when increased by 9 is the thing. So which is exactly divisible by the given set of divisors. That means if it is divisible by like something like 3 and 5, it will be divisible by their LCM 15, 3 5 15 also. Same way here, if it is divisible by 13, 15 and 23, it will be divisible by their LCM. So that means what we can say, first we are interested in finding the LCM of these three numbers, 13, 15 and 23. The point here is all the three numbers are, except that 15, the remaining two are anyway prime numbers. 15 is having the prime factors 3 and 5, which are not containing obviously in the remaining two numbers. That means the LCM for these three numbers will become simply their product. And to get the product at a faster rate, we will go for this one. 15 20s is basically 300, 15 3s is 45. So we will go for 13 into 345 as the first step for finding the LCM. 13 300s and 13 40s, 13 5s, in that way we will separate them. 13 3s is basically 39 means 13 300s will be 3900. 13 4s is 52 means 13 40s will be 520 because 4 is in 10th place. 13 5s is basically 65. So adding them, what we can say, 20 plus 65, 85. What we can say about the further one, 9 plus 5, 14 and 1 will be adding or what we can say carried forward there. So it will become 4485. But 4485 is the LCM. But the question what it is saying here, after increasing that number by 9, it should become divisible by those three divisors. That means the original number should be what? 9 less than what we are getting the LCM. So 9 less than 4485 is our answer. So answer should be what? 4476. So answer for this question should be 4476. One more way of looking at the calculation here is, these three are basically what we can say, these two are odd numbers. That means their product will be an odd number. Into 5 will be an odd number. So if you are getting the LCM as, a multiple of 5 ending with 5, LCM as a number ending with 5, from that if we subtract 9, it should basically end with 6. So that means if you are looking at the choices, there is only one number which is ending with 6. So that is the easy way of getting the answer if you are having the choices given this way, right? So let's look at one more question on numbers, right? Let's look at the concept based on that one. What is the concept involved? We'll just quickly look at that. This is mainly dealing with reminders. Find the remainder when 2 power 2400 is divided by 9. For finding the reminders, there are different approaches. One of the approaches is using pattern of reminders. That is pattern method we consider. The other one is basically remainder theorem method. For this session, we will be mainly focusing on pattern method. Like pattern method is mainly focusing on what is the pattern of reminders that we will be having when the successive powers of the same number is divided by the same divisor. Like powers of 2 only. 2 power 1 is 2. If we divide that by 9, remainder will be what? 2. Because 2 is less than 9. 9 goes 0 times, remainder will be 2. 2 square if we divide by 9. 2 square is also less than 9. So remainder will be the number itself, that is 4. 2 cube is 8. 8 is also less than 9. So remainder will be the number itself. So 8 if we divide by 9, 9 will go 0 times, remainder will be 8. 2 power 4 is 16. 16 if we divide by 9, 9 will go 1 time. Remainder will be 16 minus 9, 7. 2 power 5 will be 32. 9 3s is 27. So 32 minus 27, remainder will be 5. 2 power 6 is basically 64. 64 if we divide by 9, 9 7s is 63. Remainder will be 1. Once we get remainder as 1 in the pattern of reminders, next time onwards the repetition will be there. Just for our understanding, we look at whether the repetition is taking place in the immediate next step or not. 2 power 7 is 128. 9 14 is 126. So the remainder will be what? 2. Is it same as the first one that we are having there or not? So that means what we understand, the repetition is taking place after 6 powers. This repetition which is taking place after 6 powers, that is basically we consider as cycle. The cycle of reminders is basically having a, the reminders is having a cycle of 6. That means they repeat after every 6 powers. Now once we know the cycle for the given divisor and the the number and the divisor, we need to express the index given there in terms of this cycle. That means 2 power 2400, we are interested in finding the remainder when it is divided by 9. So what we will do is we express the 2400 in terms of 2 power 6. Right? So what we can say is, I'm just writing in terms of 6 only, not whole power case. So 6 400s is basically 2400. So we will write it as 2 power 6 into 400 divided by 9. So once we express the given index in terms of the cycle, if we have any remainder, we take the remainder. No remainder, we consider the cycle portion here. So as there is no remainder, we are not adding anything like plus 1, plus 2 in that way. So we will be considering only the cycle portion. What is the cycle portion here? 2 power 6. 2 power 6 if it is divided by 9, what is the remainder that we get? 1. Already we have dealt with that one. So that means 2 power 2400 if it is divided by 9, then also the remainder will be 1. So what we can say, answer for this question should be 1. So finding the remainders is mainly dealing with one of the approaches is pattern method. Remainder theorem is slightly time consuming depending on the divisor and expressing that in terms of powers of that given divisor with plus or minus 1, all those will be slightly time consuming. So that is the reason we are going for pattern method. Let's focus on one more question dealing with basically divisibility rules. The 10-digit number 4P2Q135123 is divisible by 9. If P minus Q is 1, what is the value of P and Q is the question. So when it is divisible by 9 is the point that we are interested basically. When a number is divisible by 9 means when the sum of the digits of the number is divisible by 9, entire number will become divisible by 9. Like if you are considering a number like 63, what is the sum of the digits? 6 plus 3. Or if you look at 63 is divisible by 9. Same way 6 plus 3 is divisible by 9. If you look at something like 126, sum of the digits is what? 1 plus 2 plus 6, 9. 9 is divisible by 9. Even 126 is also divisible by 9. So same way here, the number is given to be divisible by 9. So that means sum of the digits of that number 4P2Q135123 If we add the sum of the digits, it should become divisible by 9. So 4 plus p plus 2 plus q plus 1 plus 3 plus 5 plus 1 plus 2 plus 3 should become a multiple of 9. So how much is sum of these numbers we are having means, what we can say, 4 plus 2, 6, 6 plus 4, 10, plus 5, 15, 15 plus this is 6. So what we can say, 21. So 21 plus p plus q will be having as the sum of the digits. Equate this one to the nearest multiple greater than the constant value that we are having. What is the constant term here? 21. So 21, more than 21, it should be equated. Nearest multiple greater than 21 for 9 is 27. So what we can say is, equate this 21 plus p plus q to 27. Then what we can say, p plus q value will become 6. So p plus q is 6. And we already have the given data saying that p minus q is 1. Right? But the problem there is, if we are adding those two values, 2p is equal to 7 will be having p is not an integer. So that means what we understand is, the examiner is not interested in equating you to the nearest multiple. He is interested in going for even the next higher multiple. So what we will do is, we will equate it to 36 instead of 27. If we go for 36, what we can say, p plus q will become basically 36 minus 21, 15. So we will go for considering p plus q as 15 instead of p plus q as 6, because that will be giving us non-integer values for p and q. So if we have p plus q as 15 and p minus q as 1, adding them, what we can say, 2p is 16. That implies p is 8. If p is 8, what we can say, q has to be 7. That means the values for p and q should be 8, 7. So sometimes we have to be a little bit careful like this one, because p plus q as 6 is not giving integer values. So that is the reason we are going for the next higher value. So that way we can answer the question at a faster rate. And one more way of dealing with the sum of the digits is, as long as you get sum of the digits as 9, we can ignore that one. Like 1 plus 3 plus 5 is what? 9. We can ignore that. Same way 1 plus 4 plus 2 is 6 plus 3 is 9. We can ignore that. So simply we will be considering p plus q plus 1 plus 2 should be equated to a multiple of 9. That will become much faster rather than blindly adding them and equating it to the nearest multiple of 9. So that way we can answer the questions based on divisibility rule for 9. Right? Let's look at the next one. Mainly the discussion till now is on divisibility rules, finding the remainder, finding the LCM and HCF. All those things we have focused. Right? Prime factorization is one of the important aspects that we have to keep it in mind while dealing with the questions on, what we can say, finding the number of factors or number of ways in that way. So that way we can deal with the numbers topic, and it is a huge version, but we can definitely crack the questions based on numbers using all these concepts strongly. Thank you all of you. All the best.